All right. Hello and welcome. Thank you everyone for taking the time to join us today. My name is Jahan and I will be moderating today's webinar, which will be a conversation on various topics in algorithmic trading and a presentation on concepts in C++. It looks like we have another fantastic turnout with over 500 people registering for the event today. So I won't waste too much time before inviting the panelists on for the talks. Before I get to that, though, I'll just go over some quick housekeeping. So very shortly, we'll be sharing a poll with everyone, which should only take about a minute to answer. This will help us understand who we have in the audience today and help us tailor the content accordingly. If you've attended one of our webinars before, you might already know that we have a fairly active Telegram group on the topic of algorithmic trading. You can join this group by using this QR code. I'll also post a link in the chat. Let me just do that now. So if you open up your chat, you'll see I've just posted a link here. So you can also use that link. This group, it's a great place for us all to keep the conversation going long after the talks today. So if you're joining the group for the first time, please do introduce yourself and let us know where you're based geographically and what brings you here today. Right, before I get to the agenda, I'd just like to say a few words to thank our sponsor, Durlston Partners. Durlston are one of the global leaders in technology, quant finance, and digital assets recruitment. They've been around for over 12 years and have built strong relationships with some of the top hedge funds, family offices, and ultra high net worth individuals across the world. If you're interested in a conversation to discuss your career, please reach out to Ran. You'll see his LinkedIn profile there. You can follow that QR code, and he can arrange a call either for an immediate search or to at least build that long-term connection. I'll also leave a link to his profile in the chat as well, just there now. So you can connect with him directly there. Their website, durlstonpartners.com, is another great resource. So you can actually go on their website directly. They have a section here, roles, and you can see they've got all kinds of roles here across various regions in APAC, EMEA, and New York, and kind of Americas. You'll also see that they've got remote roles as well. So that's worth checking out for sure. Okay, let me just jump into the agenda. So first up, I'll invite Anthony Peacock and Richard Hickling. We'll have informal conversations on the techniques, C++ or otherwise, that can be used to achieve performance in a high-frequency trading environment. Next up, Rainer Grimm will be giving us a presentation on concepts in C++. He will be showing us some interesting ordering and equality ideas in C++ concepts, which leads to some elegant ideas. Finally, I'll invite Anthony and Richard back again for a second conversation to discuss some of the key roles within a trading operation. They'll also cover topics on career progression, remote working, and visas. So do stick around for that as well. As you might see as well, we have a Q&A. So if you click over on your Zoom panel, you'll see a button Q&A. So feel free to ask any questions throughout the webinar, and we'll get to them whenever we can. We will have a time at the end to go over those questions. So do ask questions. I believe also you should be able to upvote other people's questions. So if you see a question that you would like to see answered, just upvote it, and we'll make sure we cover that. All right, great. So let me just invite Anthony and Richard on. If you guys, yeah, all right. Good to see you guys again.
Hey, how's it going?
Yeah,
likewise.
Yeah, so we asked around and asked some people what kind of things they would like us to cover, and we got quite a wide range of responses. And there's maybe no particular order I can go through these questions, but so maybe I'll just kind of jump in and we'll start with what we have. So one person asked, are machine learning techniques feasible in high frequency trading? So either,
Well, I saw that question. And I thought, well, it's a great question. I'd really like to know. I have all sorts of ideas, but I think Anthony might have some actual, genuine insight.
Well, I mean, absolutely. And I think, high frequency trading companies are definitely hiring people with machine learning backgrounds nowadays. It tends to be kind of at the higher level of the stack. Often it's working in Python or, using Python to bind to things like CUDA, so that you can leverage GPUs to do, very intense floating point calculations. Basically people are using that to mine data to generate, entry or exit points, and then they use that to drive their trading strategy.
Do you ever have? I always thought it would be nice to see, or a technique might be to sort of look back on, maybe a second's worth of the stack of the bids and asks in as you're trading, to sort of and train the next a few milliseconds of trading on that basis. Do you ever see anything like that?
Yeah, I mean, I've not worked on that directly myself, but I mean, there's a whole area called, market microstructure, which is basically around looking at the different levels of depth in the order book, trying to anticipate the way the direction of the market's going, and of course, trying to race to get ahead of other participants so that you're first in the queue, so that you can buy something and then sell it at a slightly higher price. And lots of high frequency trading strategies work on those kind of assumptions.
Interesting. What kind of modern C++ techniques would you say can be used in low latency trading?
Well, I think.
I mean, what did C++ 20 give you that you don't get from some of the, like, 14 or something?
Well, I mean, C++ 20 was a huge change in the language. So, I mean, I think one of the biggest things that I've seen, in the work environment from using that is, concepts which Rainer's going to be talking about. That gives you a real chance to kind of clean up and tighten your code. For that, people were emulating constraints by using SFINAE. And so, those of you who know, how SFINAE works, it's a pretty expensive technique in terms of the way that the compiler works, because to decide if a function is constrained or not, the compiler has to instantiate the class and all of its underlying functions, and then only at the end remove it from the overload set. And so that's really, really expensive. When you do, when you're working with concepts, that constraint happens up front. The compiler is able to avoid instantiating functions. And so, one of the things I think we've talked about previously in the webinar is the amount of template metaprogramming that goes on in low latency trading, partly because it allows you to calculate things at compile time. Well, that has a huge cost on compile times, and so these kind of techniques can be really used, very effectively to optimize your compilation process. I think one of the other areas that we were, I've been very interested in is coroutines. So coroutines provide a completely different way to rewrite your asynchronous stack. And so anything that's talking on the network, of course, is going to be listening, largely via callbacks, and that means you're working with asynchronous continuations. Anyone who's wrote code like that knows just how mind-bending it is, and how difficult it is to try and write clean code like that. Well, coroutines give you a completely different way to write asynchronous code. You can use the structured mechanisms of the language to use effectively function blocks and things like that to dictate the areas and regions of the asynchronous code. So that's a huge cleanup in the language.
I always find that it's sort of quite interesting and sort of ironic in a way that when the first I knew of coroutines was a long time ago, before some operating systems were really providing proper preemptive threads, right? Back with some versions of Windows and with and early Linux, where they would have you wouldn't have the operating system properly preempting and therefore giving you, allowing your threads to be sort of parallelized by the operating system. And so you would use things like coroutines in order to get something like that in your actual code, just to have something thread-like. But of course, now we don't want threads. The reason we use coroutines now is so that we can have something thread-like without having the operating system butting in, right?
Absolutely. I mean, it's really important, particularly in a high frequency context where, you want one thread largely running at full speed. You don't want to do any kind of context switching because context switching is slow. And so, having this different model of asynchronous programming gives you, a huge set of tools that you can use in that.
Yeah, that's right. It's sort of full circle, in terms of the history of the language, we're back in the old days in a sort of way.
Yeah, I mean, absolutely. I mean, I think coroutines were invented in the 1950s, so it's only taken 70 years to make it into the language. Well, C++ isn't that old, but it's taken a long time to make it into C++. Whereas you look at other languages, a lot of them have had coroutines for a very long time.
So, I mean, outside the realm of C++, I mean, other techniques, other aspects of low latency trading, could you say anything about avoiding allocations, kernel bypass, even measuring performance, and the types of hardware, FPGA, memory map files, cable fiber, and so on?
Absolutely. I mean, I think one of the things worth mentioning that, in the high frequency trading domain, you tend to measure what you call tick to trade. So that's the time that, the data comes off the wire. You want to be responding to those bytes, interpreting them as the underlying protocol that you're communicating with the exchange from. You then need to build your representation of the market, which, is going to be your order book and all the levels for the instruments that you're trading. You then, you need to make some kind of rational decision on that. How do you get into the market? What are you trying to do? And then you need to get messages back out, out via the order execution gateway, which tends to be over TCP, and you want to get the message back to the exchange and the exchange to place your order before anyone else gets there. And so, it's really important to take measurements. I think everyone knows that in high frequency trading, we tend to use co-location. So that means, in the exchange, where the exchange servers are, every company has their own servers in next to the exchange's servers. Companies spend huge amount of efforts configuring their hardware specifically, to reduce latency. So, if you think about the wires that the electrical signal has got to go down, if you're running at 3 gigahertz, then 10 centimeters is 1 clock tick at the speed of light. And so, if you can shorten your cable by 10 centimeters, you're 1 clock tick ahead of the competition, and things like that really do matter. And so, I've heard stories from our network engineers that people were having specially configured hardware that changed the orientation of the network card because it helped them to reduce the size of the cable. And companies will spend a lot of money on things like that. But all of these kind of performance concerns are critical. In terms of measuring this, as I say, you measure the tick to trade. I think in any kind of anywhere where performance is critical, you need to have benchmarks. You need to be able to measure that. One of the things you want to do is make sure you're not putting any changes into your code which are going to degrade performance, because that might be the difference between making money or not making money. And of course, from there, you're always looking to improve.
I mean, talking of clock ticks, would you get down to the level of looking at assembly code and walking through each step of that?
It's certainly done. I certainly have done that in previous roles. I think it's not uncommon to use simmed intrinsics. I think where possible, you're trying to use techniques that encourage the compiler to do auto vectorization. I think we all know modern compilers are really smart, and it's much easier to write code so that it auto vectorizes and does that for a whole range of configurations rather than put in intrinsics which tie you down to one specific instruction set. I think I was at an interesting talk at C++ London yesterday where somebody was talking about this. I mean, the other thing you have to be very careful about is when you change between different instruction sets, your CPU can change the speed that it runs at. It can change its clock frequency. And so all of these kind of things are critical in trading, and you really need to be careful that you're not doing anything which is in effect encouraging the CPU to run slower than it can.
Yeah, interesting. I have a question here, which is kind of a bit broad, really, but I mean, what calculation speed should you aim to be competitive? Would you be aim for to be competitive in high frequency trading? I mean, you would say as fast as possible, but is there kind of like
you would? Yeah, I mean, certainly talking to the guys who do the FPGA programming, they're talking in nanoseconds. They're trying to put dedicated hardware that responds to the network signals, bit by bit as it comes off the wire and responds as quick as possible. And so, in the domain of high frequency trading, one of the things that you tend to do is if there's big moves in the market and you're unsure, the safest thing to do is to pull all of your orders. And so that's one of the things that people are using FPGA for. They listen to the bytes. If they see an uptick in movement in the market, you pull your orders. Then if somebody else can't reprice faster than you and realize you're leaving a load of liquidity at the wrong price in the market, you use the time that you've then got to reprice using your pricing algorithm, which is probably going to be slower than the speed at which you can respond to the market. And then once you've worked out what the fair price for the market is, you're going to reinsert your bid and your offer on either side of that.
I suppose you've got the kind of ultra high frequency world, and then almost like a spectrum where it gets more low frequency, and you've got people running models. Even in MATLAB, I've seen some funds actually running their models in MATLAB, and it would output a signal much slower than it would, in a more advanced setup. So, how discrete would you say that spectrum is? I mean, is there like even could you get away with some types of trading where even a 1 second latency is okay, just because the nature of the model?
I mean, absolutely, and I think any high frequency trading business, if they've gone to the effort of building the infrastructure to be able to get market data and respond at low latency, they're also going to be looking at other discrete time samples. And so, if companies can also trade in terms of years, taking long-term fundamental decisions, that they're going to make those kind of decisions as well. And it's very possible to have two types of strategies running in unison, which actually help to reduce your overall risk as a company. Because if one market you might be losing in, you might be covered in the other market. And I think that kind of security gives businesses, a kind of safety net.
Yeah, definitely. You may have mentioned this already, but how do you think you can take advantage of parallel algorithms in high frequency trading? So possibly what you were mentioning before, CUDA, and kind of using GPUs. What aspects of kind of parallel programming can be applied?
Yeah, I mean, I have to say that's not something I've used in low latency trading. It's something that I've used working in quant departments. I think it's much more kind of applicable to a domain where you're focused on throughput of calculation. With low latency, what we're trying to do is make sure that nothing takes too long. That there's you're not too many standard deviations away from the average speed that you respond to things. Whereas with working in quant groups, where they're often looking at things like what's the risk level that you're exposed to in your underlying portfolio as the market moves. They're using a lot of very complicated derivatives, and in that context, they're doing huge amounts of floating point calculations in order to do that.
Yeah. Someone asked, what is kernel tuning? So maybe for someone who's never really that familiar with the term, I mean, how would you describe kernel tuning?
Yeah, that's not something that I've done. What I would say is I've known places that were using things like Gentoo, which is a version of Linux that you can compile, specifically for the hardware that you're on. So that's what I would think of as kernel tuning. Now, this may not be what they meant, but in some cases, I've known shops to specifically build a version of the of the operating system that is dedicated for what they're trying to do on that box. I think we mentioned kernel bypass as well, which I think is kind of related, that in the low latency trading domain, you are trying to do all operations in user space, because if you make any kind of system calls, that's very, very expensive. And so, one of the prime examples would be network calls. If you're using Berkeley sockets, that will go through your operating system. That's quite slow. And so most high frequency trading shops will be using dedicated network cards with a specific library like Solarflare or Exanic are probably the two kind of prime examples. But there's lots of other cases. I mean, if in Linux you call time get time, that's a system call, and so people try to avoid that. They try to calculate time in user space, and so one of the ways we do that is modern CPUs have dedicated instructions which you can use to get a timestamp, and so that allows you to avoid going through the system to get that.
Yeah, someone actually asked that question as well. Should we avoid system calls and why? But I guess you've answered
absolutely.
it. Yeah,
you absolutely, if you can, you don't want to make any system calls.
I mean, the precise reason why though isn't it? It creates a kernel thread for the thread that you're in, and so it's the sort of the setup of these structures within the kernel that necessarily has to occur to sort of maintain the separation between user space and the kernel. Something like this, isn't it?
Yeah, I mean, modern CPUs actually have different modes of security that they operate in, and so kernels tend to operate. I think I've got this the right way around in what's called ring zero. So ring zero is a protected mode of operation where you can access instructions which in user space you can't access. So prime example would be modern CPUs have a whole load of registers that are dedicated to capturing metrics on the CPU. But you can't access them in kernel space. You have to write a driver which operates in system space in order to be accessing, you're in the ring of protection that gives you the level of access to those instructions which you don't have in user space. But the issue is that going through, switching into this different mode has a context changing cost, and that cost is, you don't want to pay that if you can.
Right, yeah. When you're in this realm of potentially, small numbers of microseconds, that relatively small cost in normal applications is actually huge, isn't it?
Well, I think that's one issue, and the other issue is it's not always guaranteed to take the same amount of time. And so, if you can think about high frequency trading, one of the things you care about is what they call the jitter, which is you're trying to make sure that you respond to things around the same time. And if you have, if you have a response time and it deviates wildly, that's probably going to be a case in which you don't get the trade placed. And so you're trying to minimize those at all costs.
Yeah, nice. So I think we'll wrap up here. We've got quite a few questions on the chat, but on the Q&A, but we'll get back to those towards the end. Someone also asked about study materials, but I believe we did answer that question in the Telegram chat, but we will share around some resources at the end as well. Okay, so yeah, as you can see, we've got quite a few questions on there, so that's great to see. And please do keep asking questions, and if you see a question you'd like to see answered, you can upvote the question here, so we can make sure we'll get to it in that order. So next, I'll invite Rainer on, and Rainer will give us a presentation.
Okay.
Concepts.
I assume you can hear me, only to be sure.
Yeah.
You can hear me?
Yeah, I can hear you.
Yeah, okay, only to be sure. Second, I start, and I'm happy to talk about concepts because I have to say it, I'm a big fan of it. So you cannot expect, I am biased. Anyway, I'm a big fan of concepts. I have also to say, when I give a class, it takes me 6 to 8 hours to talk about concepts. Meaning I would skip a few features when I would do it in 50 minutes. And this is what I do now. Therefore, what I want to do is to give you a motivating example for concepts. And here's the problem. I have an account. Okay, this account has money, and I want to compare two accounts. And what I have written here is a function template, which of course accepts all types. And when I execute this function template, it happens what should happen. This is smaller function templates works for doubles, but it does not work for accounts. Okay, quite easy. I cannot compare accounts. And depending on the type I use, I get a more ugly or more verbose error message. When you really want to have a really verbose error message, try to sort a std list with GCC. This is a lot of fun. It does not work. Okay, so what should we do? of course, I'm here to say something about concepts. Okay, let me introduce or let me define a concept. This is a concept, you see. Here I specify for two values or arguments of the same type T, I require that A smaller than B is defined first, and that the result, what this function gives back, is convertible to Bool. This is a concept. And now I use directly here the concept. Before I used here type name. Now I use a concept. By the way, I'm not done with my explanation. This is not the solution, in case you are a little bit suspicious. So, okay, let's do it. Let's apply it. And now you see, okay. I got a more concrete, this is the blank error message, a more concrete error message which says constraints are not satisfied. Because this is my constraint. My constraint is that I say A smaller than B must be defined on my account. And additionally, it says account does not satisfy smaller. This is an extremely concrete error message. And the reason for this error message is that I used here a concept, you see, smaller. It's a so-called restricted type parameter. Before we had here type name, only to see the difference. This was the error message before, type name. But now I say I apply my concept. Okay, so what are concepts about? Now I give you a little bit of theory, and then I go on and I show you a few of the things. So what are concepts? Concepts allow you to express requirements to the template parameters through the interface. I said you can only use my function template if your type supports the concept smaller. They generate better understandable error message. This is today maybe not so 100% right, but bear with me. We are in the early stage of adapting concepts. They will become better. And in particular, Grimm gives quite interesting error messages. GCC and Microsoft are not so good, but anyway. Concepts can be used as placeholder for generic code. I will show you an example. Essentially, it means in all places you used in the past auto, now you can use a concept. This makes it extremely easy to use. And I want to say it explicitly. Using unconstrained template parameters in the future is a code smell, but I will come to this later. You can use concept in any case. You use a template for class template, function templates, or member function of class templates. They even support overloading on functions and specialization on class templates. Okay, this was a lot of theory, sorry. But now I will make it a little more concrete. Now I defined for my class account the smaller than operator. And when I now execute it, you see it works. Now it works because I have defined the smaller than operator. And now it works together with this concept smaller, which requires that the smaller than operator is defined. Okay, let's continue my journey. But at some point in the future, a new customer comes. And you know what the customer says? I don't want to apply is smaller. I want to apply is greater to accounts. Okay, no issue. When I can do smaller, I can do greater. Let's try it out. And of course, we have the same issue such as before. Is greater is defined for any type. And now this phase for the same reason such as before. My account has no idea of greater. It only has an idea of smaller. What should I do? Okay, I'm simple-minded. What should I do? Of course, I implement the concept greater. You see? This is easy. I implemented it and I used it here. Is this a good solution? Of course not, but I did it. Okay. And now you see, at least it works. It works for smaller, it works for greater. It works, of course, for doubles, and it works, of course, for accounts. But is this a good idea? Maybe one day later, a new customer wants to have equal, not equal, smaller than, bigger than, and all of the 6 relational operators. And honestly, this is a bad idea. It's a bad idea to implement for each relational operator a concept. You can do it. How should we solve this thing? This is the way I solved it. I look into math theory. And this is the way I solve it. I look into math theory and I peek a little bit into Haskell. In Haskell's type classes. And here is how ordering is modeled in Haskell. This is how they model ordering. First of all, they model equality. Equality means, you don't have to understand this syntax, equality essentially means equality is supported if equal is supported and non-equal, and it requires for 2 types of the same type, 2 values of the same type A, that it returns a bool. This is the concept, not a concept, I say concept is a type class similar to concept, type class equality in Haskell. And they make an abstraction. They say, voila, to support ordering, you have to, in order that A supports ordering, it has to support equality. And these additional requirements must be satisfied. Smaller, smaller equal, greater, greater equal. And this is how it's modeled, and this is how math works. Because Haskell was created by people with a mathematical background. And now this was my challenge. Can we do that in C++? Of course we can do it. If not, I would not show it to you. Have a look here. I model here the concept equality. And you see this looks extremely similar. I say 2 values of the same type T model equality. If they support equality and inequality, both converted to bool. And then I refine this concept by saying, what is ordering? For type T to support ordering, it must first support equality and additionally support these 4 additional requirements here. And these are the remaining relational operators. And when you compare this, I ignored compare and max. When you compare this, this looks extremely similar. But, and now let's try it out. And this is what I did. You see, these are my concepts, my 2 I use here. I apply them here in ordering. Now it works. But I made a small trick, which I didn't mention so far in my description of this talk. I used here the spaceship operator of C++20, which automatically generates the 6 relational operators, because I don't want to implement all of the 6 by myself. And I can default it. This is an additional C++20 feature. And this is a solution, I would say, which is fine. Okay, let me go one step back because I forgot one point. Why is this a bad idea this year? Why is this a bad idea to implement for one concrete operation a concept? Concepts, and here's the thing why I love concepts. Concept should not model syntactic constraints. They should model semantic categories. What is ordering? What is a number? What is arithmetic? What is equality? Things you know from your math theory. This is what concept should model, and not just a syntactic constraint. I need smaller here. This is nonsense. Because you want to reason about your program from a way, way higher level of abstraction. But I have to admit, don't use these concepts here. Why? They are predefined in C++20. You see it here, we have the concept equality comparable, and we have the concept totally ordered. They are similar to mine. And here are a few concepts which are already predefined in C++20. same as derived from, you can see it. What is integral? I will use it. So what's integral? Essentially something between bool and long int, signed integral, unsigned. What is a floating point? What do we regard as a floating point? Also interesting concepts are, a very interesting concept is regular. This is a type which behaves extremely well in the C++ ecosystem. It supports the big six and is swappable and equality comparable. This is a key idea of the standard template library design. And additionally, we have concepts such as invocable, or what is a predicate, a function which takes two arguments and returns a boolean. This is a predicate. So we have a lot of predefined concepts, by the way, way more than here, but I only showed you a few of them. Okay, a few additional words about the theory. You can use concepts in 4 different ways. I used so far this way. This is called restricted template parameter, meaning instead of class or type name, you write here, use your concept. But you can use it also in this way. You say, this is a usual template declaration. You see template type in T is smaller. And here you put a requires clause in between. And here you say, okay, T must require ordering, whatever that means. You can also use a trading requires clause. You put it afterwards. This is extremely elegant when you use it inside member, when you use it for member functions. This makes it more concise. And here's something which is extremely interesting. You know what? The last line. And this is extremely interesting. When you use a concept in a function declaration, this has, by the way, an aptly named abbreviated function template syntax. When you use a concept in a function declaration, this becomes implicitly a function template with the type constraint provided here. You see here, only 2 orderings can go in, and something which is supports ordering goes out. This means in C++20, when you define a function, once more, a function, not a function, a function, and you use a concept inside, this becomes implicitly a function template with this type constraints. And this is extremely nice because now defining function template is as easy as defining functions, and you are used to it, I assume. Okay, now you may ask me, when can we use a concept? And the rule is extremely straightforward. By the way, I love straightforward rules because I have to explain it. And when I only can say something about exceptions, this is terrible. And this is extremely straightforward. In any place you used in the past auto, you can use now a constraint placeholder. Let me go one step back. In C++20, we speak about constrained and unconstrained placeholders. Unconstrained placeholders are the autos you know since C++11. There's no constraint in it. Constraint placeholder is a placeholder which uses also a concept. You see it, stood integral auto. This is a constraint placeholder. So you can use it here as for specifying the return type. You can use it here, for example, in a range-based for loop. You can use it here to accept the B. You can use it here to accept the integer, and only to show it to you, this is the C++11 syntax. This is once more an unconstrained placeholder, and this is a constrained placeholder. And you know what? You can assume in the future that you will not use this stuff anymore. You will switch to this stuff because this gives additional semantic meaning, and also the compiler will check if you do something wrong here. But here there is no check, of course. Auto can be anything. Here's the example to it, but I will skip it because it's exactly what I have here. Okay. And now to the final question. So once more, this was a motivating example. To the final question. Are concepts an evolution or a revolution in C++? I have, of course, an opinion, but here are the arguments for both classes. Okay, we have auto since C++11. Okay, it's only a revolution. evolution. Okay, since C++14, we can use generic lambdas. You see, here's the auto, which also creates under the hood something function template-like. This is the part for the evolution. Here's the part for the revolution. First of all, this is the first time template requirements are checked by the compiler. This is something totally new. I ignore tricks such as VNAME. Second, the declaration definition of templates is significantly simplified. Look here, this is easy or not? You just write your intention down. And here's my main argument for revolution. Concept defines semantic categories and not syntactic constraints. Now we can reason about our programs and say, you can only invoke this function in case you are a number. We have to think about what is a number, what maybe it should support plus, minus, times, and multiply, and we can express this. We can express ideas such as order, such as what is a regular type. By the way, informal term for regular type is it behaves such as an int, to make it short. But now we can discuss it on a way higher level. And this is my reason. This is the reason for me why I say concepts are a revolution in C++. If you don't believe me, here are two things which you can read to get the remaining stuff. Once more, it takes me usually 6 hours to explain all of it. First of all, I have written around 30 blog posts about it. And then when you use this thing here, you will jump to my blog post. First, second, I have to count in the right way. Of course, you can read my book. About 20.
Yeah.
Okay.
Yeah.
I'm done. I'm not sure how long it takes, but anyway.
Yeah, no, that was really interesting. Thanks a lot, Rainer. Actually, we had a conversation before we started, which I thought was interesting. I think one of you mentioned that Barney Stroup actually conceived the idea of concepts before, even writing the language. Who was it?
Concept have an extremely long story in C++. And I have to kick in because I like this joke.
Yeah.
All important features were removed from the standard when we had a meeting in Germany. And concepts were removed from the 2011 C++ 11 standard in 28 in Frankfurt. On contracts, Hubsutter's main feature were removed in Cologne, I think 2018 or 19. So we see, always we have a meeting in Germany, something bad happens.
Yeah. Was it quite a heated meeting? Was there some argument?
I don't know, I was not there, but I know this discussion. It's just funny.
Yeah, that's quite interesting.
Yeah.
Actually, let me, I haven't sent around the poll yet. Let me just send that around while we're here. I forgot to launch that. So do answer that poll if you have a chance. Yeah, what about you guys, Anthony or Richard? Any thoughts on concepts?
Yeah, I mean, just to add, as you were saying, I mean, it was one of the features I think that was in the original. I think it was the book, The Design and Evolution of C++, which is Bjorn Stroustrup's original book. And if you ever go to the standard committee meetings, one of the things they say to you is, you should have read this book because it kind of lays out the framework and the thinking that Bjarne had about the language and what his intentions for, what was he trying to solve with C++ effectively. And even though it's an old book, it's still, it still has a lot of that message that's kind of very important to the thinking of what we're trying to achieve with the language.
Let me show you something. This is the designer, Alexander Stepanov of the Standard Template Library. He is the guy behind the Standard Template Library. He built these ideas of concepts already in the Standard Template Library. But before we had them on a language level, there were only documentation hints or something like that. They are baked into the C++ Standard Template Library. And the guy behind this is Alexander Stepanov. which I'm sorry to say it, but I never met him personally because I'm a big fan of him.
Oh,
But now he's retired, you know. Anthony, do you ever met him?
I haven't, but one of the things I was going to say is he's got a whole series of lectures
Yeah, I
on,
know.
on YouTube from his time at Amazon, and they're really well worth a watch.
He was wasn't he at HP when they did originally the STL? It was Stepanov and Lee,
That's right.
Meng Lee.
That's right, yeah.
I remember when that came out. I'm a geek, obviously I'm a geek, but I can tell I can tell you it was exciting to read that paper. I just fell off my chair, and that's, I think, yeah, it's just interesting how these things have developed over time. When you have these new what seem like new features, but actually they've been thought of for a long time, and they're brought into the language with great fanfare. But I sort of feel their impact is as much as anything the directional change they give. So that, for instance, when they brought in when lambdas were brought in, I remember looking at. I was against it. I was thinking, oh, come on, lambdas. We're really going to have lambdas in C++. This is not C++ anymore. And I went to some great lengths to show how C++ effectively already had lambdas, because you could have local classes, and you put methods on those classes, and you could, with a little bit of preprocessor, you could pretty much make a lambda anyway. But so it's obviously the syntax is much nicer, but you can what it really said is, okay, C++ programmers, you are now sort of free to go forth and use lambdas. And the same with auto. I saw auto, I thought, oh, that's just like var in C#. It's one of the reasons I don't like C#. But I became a total auto convert pretty quick. So anyway,
Let me say one of my favorite sentences in my classes. The less you program, the better your program will be. And with auto, you make no type decision because the compiler makes it for you. This is something I often prove. Let the compiler do the complicated stuff.
Yeah, absolutely. And what you were saying about concepts with auto, I mean, it just brings everything together, because there is sometimes a loss when you use auto rather than declare your type. Sometimes you would prefer to put your type there explicitly, even if you could use auto, because it's sort of clearer. Now with concepts, you sort of get both sides, don't you?
Exactly. And now you develop from a higher point of abstraction, because you don't say you want to have an int on W, you say you want to have something which behaves such as a number. And this is a way more abstract way to think about your program. You don't care if it's a float or double or what else. It just should behave such as some floating point thing.
But maybe
some number.
See, what I saw with basically every version of the standard is, and this is what Strustrup, how do you pronounce his name properly? Strustrup. So I say.
Use his first name.
Okay, Bjarne. So what he was saying is, I think after C++11, it feels like a new language. And I think that was really the same with every standard. It feels like a new language. And the primary way, I think, that C++20 is feeling like a new language is concepts. And it will changes the way, for instance, if someone's new to C++ starting right now, well, the reality is they probably won't get to use C++20, but just say that that's what they're going towards. They should learn the new language, rather than and try to, quite honestly, find companies which are using the new language too.
Okay, you don't have to go on the embedded domain, but anyway, I have classes which still fight with C++11 because due to strange compilers.
Right.
Nice. Just a quick reminder, if anyone hasn't joined the Telegram group already, please do so using that link. And if you also introduce yourself as well, I think it'd be good to let everyone else know who we got there on the chat. Right, I will move on to our next talk. So conversation again, back with Anthony and Richard. So now we're going to talk a little bit more about a career in the industry and the types of roles that there are in the industry. I think this is quite a popular topic that people have always been asking us about, especially on the Telegram, and I think individually as well. People reached out to us on LinkedIn. So I think this is something that people wanted to know about. So maybe just to start with, I mean, this is kind of quite a broad question, but what would you say are the key roles in a trading firm?
Yeah, well, I mean, I think one of the, you've got to think about what a trading firm does. They're connecting to exchanges and placing trades, and so something that's absolutely fundamental is writing your connectivity layer. You need to be able to connect to the exchange and interpret that, and communicate that to the people higher up the stack, that the view of the market. And so there's definitely kind of what you would call the market gateway, the market access layer, which is talking to the exchange and building what's the instruments that are tradable, and for each instrument that's tradable, what's the order book. And so when you look at Google Finance or kind of stock chart, you see what we would call the top of the book. Like, you see what's the price that people are trading, but underneath that, there's a huge amount of information in the market about who is trying to trade a position and what price they want to trade that at. So you need to interpret the information, you need to pass it up the stack, and then there's going to be a team who are building trading strategies upon that, because you want to get orders into the market. Many trading companies have a market making business, so obviously that's a business where you're sitting on both sides of the market, but also you've got the kind of hedge fund or fund kind of way of operating, where you're looking at fundamental data, you're trying to make long-term decisions, and you're taking positions that you might hold in more what you might call mid to low, mid to I was going to say low frequency trading, but yeah, low time scales.
Would you find from your experience, those teams that are in charge of market data connectivity, would they also be in charge of storing the market data in a way that the quants and researchers can access it and run their models? Or sometimes are those teams separate?
Yeah, I mean, I think it very much depends on the organization that you're in. Some organizations have a kind of what you call the pod structure. That's like the Citadels and the Millenniums and places like that, where you have small teams, and each team effectively has its own completely separate technology stack. Other companies are structured where they have a kind of a core system that does that. That you're responsible for capturing and recording the data, and then everyone in the organization is using some common system that gives them a view of that data. And so, I think there can be a huge range in the industry. You really, if you're going to be interviewing and looking for jobs, you really want to be having a whole list of questions about the way the organization works that you take to that interview with you, so you can try and build a picture of just what it is that organization's doing and how they do it.
Yeah, the different ways in which these trading businesses are organized is to some extent, sort of a differentiator between them, and it can be more successful. You can have a completely separate organization of a trading company, which is as a result more successful in certain circumstances. For instance, I know that you were mentioning this sort of pod structure. I know that some companies that as a very firm rule want to be sort of unified across their businesses, and then therefore reuse, it's good logic, reuse your code, therefore you have less, it's more efficient, right? But others are quite different. They say, no, you know your trading environment, you know what you need, you have control, so that their derivatives business and their cash businesses will have entirely different structures, entirely different technologies, possibly different programming languages that they use. And you will find if you sort of maybe have experience in one company and then go to another expecting that they will look the same, I'm sorry, this is going to be, I would say, almost never the case. My experience in quite a few organizations has been that every single one is so different that it's a big surprise every time.
Absolutely. And I think also the other thing worth mentioning is this, with this kind of pod structure, is course, compensation can vary wildly based on the structure. And in this kind of pod structure, you are, you're much closer to the business. You're sat with the portfolio managers. They view you as one of the traders on the team, and so that probably directly links you to the P&L of that little fund. But also, if your little pod isn't doing well, you're probably going to disappear fairly quickly. Which, if you're in an organization where everything's shared and everything's visible, there's probably a lot more stability to that job than in the pod, the pod model.
Higher risk, higher reward.
Exactly that.
Yeah, that's a good point, actually. I'll jump on. Well, I'm sure we'll get back to some of these other areas as well. But someone asked, how should candidates prepare for interviews? I mean, what kind of should there's a certain amount of resources, practical experience?
I've been thinking about this question. I know what they want. The sort of the people who are asking these questions, so they want the answers, and I'll try to give some answers. But I think before that, they have to sort of step back and think about things like why they want to go towards these jobs anyway. I think everyone on this call is numerate. Probably, if you were to do a sort of survey amongst people in your area, you would find that you're one of the few very numerate people. And that most people sort of hide their lack of numeracy, and you're in a small group of people. And right now, in this economy in the world, you're going to get a good job if you can communicate well as well. You should have no trouble. What you really need is a fascination with the industry. You need to be able to. You need to know that what you're getting into is something that you are already passionate about, and you should choose before you go ahead. You should find out enough to know if this genuinely makes you excites you, and because it's going to be hard, and you need that fascination and excitement to drive you forward. So you've got to check that off first. Does this genuinely fascinate you? And I mean, I can say absolutely does. I love this, the C++ arcana of C++ and the finer points. And I love the finance industry. I could go on about, my sense of the positive morality of the finance industry, which would, some people disagree with. But given that you have this fascination, this is going to allow you, when you're in an interview environment, to be clearly to be more articulate and to naturally want to persuade your interviewer of the value of of your knowledge and how it can be applied. And it brings you into a good relationship with the interviewers, and it sort of silently helps you through. So let's start with that. It also helps you in the next point, which is when you're going for a job, this is a big project that you will work very, very hard at and put a lot of time into. You would work harder in approaching the job and trying to get the job than you will in the job typically, because in the job you will generally be of some restricted hours, and you will have time to learn. You'll have encouragement, you'll have interaction with other people. When you're preparing for the job, you're going to be working really hard, and it's so I'll just say that to start with, just to frame these types of questions.
Yeah, I mean, I might just interject here and also say, I mean, I think one of the things that's really important is that every organization is different, as we were talking about, and that extends to the interview process. And so, if you're trying to get into the industry, you really should be cultivating a good relationship with your recruiters. And there's going to be lots of recruiters, each of them having access to different roles. And you need to be having conversations with those recruiters about what's the interview process like at this place, because they're all going to be different. Some places are going to focus very technically. Some places are going to want more market knowledge. You need to build a picture of that. And that's going to prepare you much better for the interview. And I think also, then going through the interview process, you will learn a huge amount by doing that. And you might not always succeed the first time, but it's still useful to go to interviews even if you don't succeed, because you've learned something about that company. And you never know when you'll find yourself going back 5 years later, or the next time you're looking for a job, and you might be successful that time.
Yeah, that's right. obviously you need skills. You need, but what I've found when I've been in sort of intense periods of trying to get work, I've learned so much in those periods. I think, for instance, I really learned pretty much the whole of Java and in one period of interview. I didn't know much Java beforehand. I got to a level where there was not much of the Java language which I didn't understand after sort of 3 months of intensive study, and this certainly impressed my interviewers at that point. So you can do a great deal of sort of knowledge gaining in this process, and you should expect that that's what you're going to do. I think you should never expect to be able to fake it. You need to do this hard work. In this industry, when you're talking about trading, the people who employ you can't accept someone who's not got the genuine skills. You shouldn't try to blag it. You should always, if you don't know, then try to work it out in the interview. Try to show that you're capable of making the effort and under pressure to work out answers to questions you don't know. You say, look, I'm not really familiar with that area, but this is what I would do, and then ask questions. It's like, they're asking you how to increase or reduce the latency in some trade execution. You can ask, how does the network, what sort of network technology do you use in this case, and then sort of give a back and forth and build up a picture of your solution.
Yeah, absolutely. And I think the other thing I'd say from being on the side of the interviewer is, I'm always impressed when people say, what, I don't know this, and it's okay not to know it, because the simple truth is nobody knows everything. Being comfortable with the boundaries of your knowledge is, I think shows a lot of strength of character. And I think, the answer, I don't know this, but I could learn it, is perfectly acceptable.
Yeah, that's right. And it's exactly, again, from the side of the interviewer. I know other people have similar type of technique. What I tend to do is when I might start with a resume, or maybe just what the person's been talking through. I then ask about the specifics. Say, oh, okay, it looks like in your master's degree, you worked with modeling bird distributions, or something like this. How did you? What did you come to in terms of some aspect of it? All right, now how did you model that? In fact, and going into the detail, and so you should be. For one thing, very sure that if you put something in your CV, you do know it in good detail, and make sure you work through that before your interview, because I think it's a sort of an effective technique in getting to an understanding of the depth of someone's knowledge.
Yeah, absolutely. And while we're on the topic of CVs, I mean, one of the things I would say is, it's always great to see people's code. So if you have a GitHub, make sure it's on your CV, and make sure you've got, some nice examples that people can look at. Because as somebody, when you're interviewing, if you can look at their GitHub, you get so much information about their ability from that, far more than you can from a test.
Yeah.
Yeah, okay, that's right.
So maybe we'll jump on to, so a few people asked about remote working. So someone asked, is the industry more inclined to hire on-site developers than remote ones? And just a kind of general question, do trading firms generally accept remote working?
I think it, it varies wildly on trading company. Certainly my last employer, they were fairly comfortable with people being remote 75% of the time, I would say. Some companies do want people in. Again, this is where having good relationships with recruiters is really useful for building up a picture of the market and where your options exist. But as a developer, I'll certainly say my experience of working remotely is, I think it can be far more productive than being in the office, and so I think companies should be supporting that.
Well, obviously the pandemic has changed things hugely because it's in many cases proved that people can be productive remotely. Maybe it's also teased out some situations where it's not a good idea, but it's meant that this gives a whole lot of data to the more forward-thinking employers, that they can adjust their requirements and possibly even their roles so that they make that available as a possibility. I think what we're going to, but at the same time, you think of the City of London, there's a certain pretty big sort of small c conservative element there that tends to like to, for a sort of senior managers to see people in the office. And, if you've been in say an investment bank trading team or a front office team, you'll find that they are quite, they tend to want people in at 8 a.m. or before 8 a.m. and they expect them to stay until, 7 p.m. would be quite typical. And it's a tough, it's a lucrative area, but it's tough, and a certain sort of almost militaristic discipline is tends to be expected in many cases, not all, but many cases.
Yeah. Let me move on here to the questions, because we have quite a few open questions, so we'll just kind of get to that. So maybe just everyone, Reiner as well, if you have anything to say. I've sorted these questions by the most upvotes. So if you'd like to see an answer to a question, just upvote it. You're more likely we'll get through it. So someone asked, an anonymous attendee asked, what would be the best step to get into the high frequency trading career, especially using C++? They say they're working on C++ 98. As a product, it's a legacy one, and there's no room for the latest C++ version. So this is.
I think that's challenging. If you can't change your work environment, then you have to do something outside of work. And so, if I was in that boat, I would find open source projects that I'm interested in, and I would start contributing. I think, you can find a nice code base that you can learn a lot from, and then you can get feedback from, developers who are much more experienced, in that topic than you, which I think code reviews are a really fantastic way to learn. And I think, when you're in a job, that's one of the main ways that you transfer knowledge. And so it's great that you can do that with any open source project anywhere, just by checking out the code, making commits, and raising pull requests.
Actually, there's an open source project that we are kind of working on. Shall I mention the Heisenberg one, Richard?
Oh yeah, sure, why not? Yeah,
I'll just post that on the chat there. Maybe you guys should say, are you guys looking for contributions to this project, or what would you say?
I would say yes, sure we are. It's an example project. What it gives, I think, is a very small code base sitting on top of a larger code base, that's CC API, an actual running algo. Not a good one, not one you should run, but a starting point. So if you wanted to actually see an algo running in the market, it runs on the big markets. We've got the sort of FTX as our reference market, but you can start with that, and even on that, right, sort of a medium frequency algos. You can, for instance, I think in one of those I do use TAlib. So you have it shows something of the complexity of interfacing with TAlib. TAlib is a library of technical analysis functions, which is sort of basically the standard library. It's used in Python as well. It's the standard library that's open source for technical analysis. So with it, you can put together reasonable strategies, in fact. And although they, the infrastructure could be much better, could be put together in a much better way, it's a very simple starting point. So I know there's one guy who's contacted me, and I've said, look, how about use PyBind 11, which is a binding layer into Python, to provide an example algo in Python on top of this interface, and I think he's working on that now. So if anyone is interested in doing more, or maybe just cleaning up the existing code base, you should do it. First thing is you get in there, obey the instructions, get something building, run it, put $100 in your FTX account or whatever you like, and see it running. That's a big achievement to have a genuine C++ algo running in a live market, and I think you'll find that a lot of fun.
Yeah, absolutely. I mean, the project is meant to be, a learning resource for people. I think it'd be really great if we could look at interfacing that with something like QuantLib and, doing some more sophisticated kind of decision making around the trading. But it's certainly a good starting point, and it's all built using standard tools like Conan and CMake, and so it's very easy to put new libraries into it, which isn't always the easiest thing to do in C++. So.
Okay, great. Tom Chisholm asked, my skills are split between C++ and FPGAs. Are mixed roles available, or should I focus on C++? Or, well, I guess.
So again, probably depends on the organization, but I'm sure there are mixed roles. Maybe in your shoes, I might look at something like the Intel One API, which is an API which you can write C++ like code, and it generates FPGAs from as well. So there might be ways for you to use that to create examples to help push your career in whichever direction you want. But I think it's very much you need to have conversations with recruiters who have those roles when you're looking.
I would say that if you have good experience in both C++ and FPGAs, you won't be looking for a job for very long.
No, absolutely. And I know that recruiting people with FPGA experience is intensely difficult. A lot of trading companies I've talked to have made it clear that that's one of their hardest areas of hiring.
Okay. Someone asked, what are the roles and skills in high frequency trading with candidates that are very hard to find from the recruitment perspective? So like what roles are actually hard to fill, basically?
Anything with C++. I mean, right now it's impossible to find people with really high level of C++ skills, which is exactly what every trading company wants. And I think companies are going to have to start changing their approach. Companies are going to start having to invest a lot more money in training. Obviously Rainer can comment here, but I think I would expect in the next few years to see more and more companies put in place programs to develop people, people's C++ skill, because they're just not going to be able to hire the number of people they need.
Let me just kick in. I have to make a short plug because you mentioned my name. In Germany, it's terrible, honestly. I'm booked until May. There's a big demand for C++, not only in your domain, but also in the automotive domain. Germany is driven by the automotive industry. But this is not a question only about Germany, it's a worldwide question. And I have to say, I'm not a big fan of 3 days classes. I have to make additional plug. And this is the reason why I now created, and I want to implement it in a better way, or to make it a success, a worldwide mentoring program. Meaning a program which will not teach you 3 days C++, but will teach you 4 or 9 months C++, and you do it for a longer time. And this is what I now do, and I'm a big fan of it, and I'm so engaged about it because I think this is the future, not classes, mentoring. Now I shut my mouth, because if not, I would.
No, actually, Rainer, he gave this article on e-financial careers was very popular. It was, I think you had an interview with Sarah Butcher, and I think the kind of headline quote there is, C++ will be used for the next 50 to 100 years in the financial services. That's that's quite a prediction, like the Nostradamus of.
No, I'm not Nostradamus. You can always make a prediction if the prediction will stay longer than you live. Therefore, you have no issue.
Yeah.
Well, it's interesting. Actually, it isn't interesting to say that because this just recently we've had I can't remember his name from Microsoft saying that C++ is legacy, which I think is I'm not going to relative to Rust and so on. And I think there's been a little bit of chatter on LinkedIn about that, and I'm not. I would say. Well, the first thing I would say is that the C++'s death has been reported quite a few times in the past, and it would be easy to say, well, in each case, C++ has triumphed. But actually, I don't think that's what it is. What it is that we are living in an expanding universe of software. There's many more people proportionally in the software world, and so that each of these language domains has expanded. So that Java, for instance, is that sort of seemed to be replacing C++ and didn't, is certainly not dead itself. Then the JVM languages, they're expanding, and it's great, that ecosystem. And then you have a number of new languages, and just recently CPP2, Val, and Carbon coming into life, and I hope they all do well as well. They will find their niches. I just noticed that, for instance, we're talking about high frequency trading and trading systems and using C++, and maybe Rust as a competitor. But actually, there are plenty of high frequency trading operations on JVMs and other languages. That you would think, well, how come? How can they possibly? But no, they function very well, and they compete with C++, even in HFT.
Let me say something. In 1990s, people said to me, forget about Fortran, no one will use it anymore. But
Fortran,
you know what? Fortran is heavily used in Daimler. I had to write a lot of wrapper in Python to deal with this ugly Fortran command line things. This was my job. I did it as a consultant for Daimler. I wrote 4 Python scripts to deal with old legacy Fortran stuff, which was from the 60s, only to give you an idea.
Well, it's there's some massive COBOL as well. But if you look at
exactly COBOL,
you look at Fortran and COBOL, modern Fortran and COBOL, they have classes and they have methods and so on. And just recently, I was looking at PHP, and I thought, oh, terrible PHP! I don't want to touch that. Then I did a little investigation, and yep, PHP has classes. PHP has function. Function overloading and class hierarchies. And I thought, wait, it can't be. And I'd search for PHP generics. Yes, PHP has generics as well. So, it's all fine.
That's good.
I'd also make the prediction that with more and more crypto trading companies starting up, that some of those are going to be using Rust, because the crypto ecosystem is already using Rust in the implementations of certain blockchains, and so it seems like a natural bedfellow there.
Right. Yeah, and in fact, in crypto, you're going to get other languages and other. I mean, for instance, the Cardano blockchain is all on the language we were talking about before in Reiner's presentation.
Haskell
is Haskell based, because they want the benefits of Haskell's lack of side effects, that being a saving grace against hacks. So there's a lot of stuff going on in that space, which will expand our universe yet more. And
Absolutely.
I love it.
And I think many crypto places are hiring people who have Solidity knowledge, don't
Solidity,
they?
that's right.
Which is, is required for certain crypto programming.
Yeah, that's right. So the Ethereum blockchain, basically, yeah. So it's interesting, and it's exciting, and there's plenty of work there.
This is quite easy to answer. When a programming language has such amount of people which use this programming language, the programming will not die in the short term. Because this is how our industry works.
Sure. Yeah.
Let me move on to a question from Thomas McNally, who asked, he's a Python engineer who's considering getting into high frequency trading. And he asked, would you guys say that a strong background in maths is required to excel as a high frequency trading engineer?
It's certainly useful. Absolutely. Yeah. Is it required? I don't think it's required, but I think it's it's very common to see people in high frequency trading with those skills. So yeah.
That might, so like outside the quant research, the kind of quant side, where does it get, why is it helpful in kind of a more maybe developer type role?
I think it's the kind of structure that maths gives you to the way that you think and approach problems, which I think, if you think about programming, they're very closely related. And programming is like big puzzle solving, isn't it, on some scale? And so I've certainly worked, I think about my last place, a couple of the guys on the team had degrees in maths, but they were fantastic C++ programmers. I don't think you have to have it, because I don't have a particularly strong maths background, but it certainly is common to see people who do.
Yeah. Okay, great.
Yeah, maybe it's things like data structures, concepts like data structures and algorithms. I mean, if you are to sort of you look on Wikipedia and at say binary trees or say search algorithms which use binary trees, sort of to see why it is that maths comes to the fore. If you read through those, you read through. I think there's a search Wikipedia which talks about the different types of search algorithms you've got. You can see it's the help that maths will give you there. Otherwise, there'll be concepts that are you have to work through on the spot.
If you haven't already, maybe have a chance to upvote any questions you'd like to see answered, because we probably won't get through everything today. We'll try and answer them again maybe in a future webinar, but I've sorted everything by the most upvotes. So do have a look through those questions as well if you want to answer. Someone asked, Richard, what's that blue algorithms book you have behind you?
The blue one.
No, you didn't. It's not algorithms. It says Argentina.
Oh, it says Argentina.
I can tell you about Argentina if you like. No,
yeah.
But well, is there some way I can bridge Argentina and algo trading? Well, with crypto, there's a lot going on in crypto in Argentina.
By the way, Richard, I have a nice idea. We have a GitHub repository. It would be nice if you put a few resources which are necessary for your domain inside this GitHub repository and just then it call it resources or something like that. Meaning books, meaning articles, meaning stuff like that, videos. Anyway,
this is a great idea, and I was actually putting that together, but then Jahan had what may be a better idea. You tell us about it, Jahan.
Okay, sorry, this was my idea.
No, it's fine.
Anyway.
I mean,
the same idea.
There's many ways we can do this. I mean, one way is actually to make a massively collaborative Google spreadsheet, and actually we'll share the spreadsheet around, and people can, it can get incredibly messy. I'm sure there'll be no nefarious activity on the spreadsheet, but the idea would be that we share the spreadsheet and with some kind of organized kind of scheme on it, and people can just add links, share things, and basically just be one big resource. It might be a bit messy to start with, but hopefully over time we'll find a way to kind of
you need maybe a kind of moderator to say this is a good resource and this is not so good. So someone has to make a decision.
Or we could possibly have some sort of voting scheme on it. But I mean, put it this way: I think what Jahan was described to me before is allow the community to try to put in its own. You see the community give its ideas. Actually, it makes me think about something I discovered from GitHub recently. I'll put in a link to this. Just a second. Where's our chat? I'll put this in the chat. A little while ago on the Telegram, a guy said, "Hey, can you say what are some resources?" Pretty much the same question you had, and I thought, yeah, that's interesting. Well, in particular about open source open source resources, so that people can, for instance, get started with their own projects. And he said, well, everything's closed in this industry. It's very hard to get some. I said, no, I know there's plenty out there. And so I suggested a couple. And then I thought, well, GitHub has such a huge number of these, and in fact GitHub has its own rating based on stars. So I put together a little bit of software there that sort of based on a popular repo pulls back other similar popular repos, and that's something that might help people as well. But I think that people's actual decision making based on their own experience is more valuable than an automated system in this case, and that's what we'll get. Like, for instance, people have put forward Carl Cook's great webinar from like 2017, not webinar, CPP conference talk from 2017, when a second is an eternity or something like this. I think it's microsecond is eternity, and few people have put that forward. There's some particular resources which are really useful, and we'll get going. We'll sort of seed. We'll put together this spreadsheet. We'll seed it between us and through the Telegram, and see what it can be made into.
Yeah.
Okay.
Actually, if you see that on the Telegram group, you can actually see there are already quite a lot of links shared already. So I mean, there's just a bunch of
just
things.
Put it together.
Yeah. We'll need to organize it, but put it together.
Yeah.
Yeah. Let me get to the next question. I guess this is the same idea. Can you suggest good books to read for C++ algo developer? I guess, yeah, we'll share that spreadsheet or whatever that medium is around at some point soon. And we can,
other than Reiner's book there, what's sort of a big one at the moment?
Well, I mean, this was the one that, we were recommending, the C++ templates book. It's only C++ 17, but it's got a lot of really good technical information, and it's not, I wouldn't say an easy read, but it's very advanced template usage.
I have to say there's an additional good book now available for templates. It's called Template Meta Programming from Marius Bang. I don't know exactly his name. This was published 2 or 3 months ago. And this is a little bit easier to read, but also gives enormous interesting information.
What was it called again?
Template Meta Programming from Marius. I will write a review about it in a few weeks.
Okay.
Marius, I will find it, and when you give me the screen, I will find it for you, and then I put it inside the chat window.
Okay, great.
Right.
Marius template meta programming.
Yeah. Jakob asked, what's the typical tick to trade you see expect from C++ in like 95 and 99 percentiles? And will it differ in arbitrage versus market making versus other domains? So I guess this question is about, what kind of what's the distribution of latency you expect across, the full stack?
Almost certainly it's going to differ based on which exchange you're talking to, but you're certainly going to be looking at milliseconds, and for the hardware guys, the FPGA guys, they're talking nanoseconds.
And did you have tools whenever you were on the trading desk? Would you have tools that actually monitor your latency?
Well, in the software stack, we certainly it was built into the software stack to track that. I think every trading company I've worked at uses a huge amount of logging, and so sometimes a big part of the job can be analyzing those logs. Obviously, every message in there is time stamped. Inevitably, you're going to want to use a huge set of tools like things like Intel vTune is obviously essential when you're doing any kind of performance benchmarking. I think I mentioned it on the chat group. Jane Street have a tool that is open source called Magic Trace, which uses a whole load of registers in the CPU to capture metrics, which is super useful, and then also uses a Google performance framework for displaying that data. So I think those are tools that absolutely you should be looking at using if you want to kind of really drill down on performance.
I think I'm not sure if I saw a question earlier about multicast. What would you say? I mean, the advantages of, say, for instance, if you're in a multi-class environment, having some logic to drop messages when not to, if you're trading in an environment where basically it's not a snap every 50 milliseconds, it's basically you're just getting a full stream of quotes and trades and prints at the same time. And maybe there's times when there's too much data really that you can handle at once, and there's some trade-offs that you have to make with maybe you drop some messages. So what would you think about that?
I mean, I think, if you drop messages, that's a problem because you're going to have inconsistent order books. And so you can't trade on that. You have to process all messages. And, every single exchange protocol has a system for recovery because, you're using multicast, you are going to drop messages. I mean, most cases you shouldn't, but it will happen. And when it does happen, you need to be able to reconstruct an order book and make sure it's consistent with the market view. Otherwise, you're trading against incorrect data, and that's going to cause serious problems.
Yeah, I was thinking more on the application layer. So once once it comes into ticker plant, it's all being processed, and maybe just sending top of book to the strategy. Maybe the strategy.
It's certainly the case that you will broadcast data around the company. So you'll have one, for each instrument that you're interested in, you'll probably have a single executable pinned to a single thread that has complete resources to itself that is processing that data. And then you'll be using multicast to broadcast that around your organization so that other applications can listen to that data stream and then trade against that. If you're doing trading that's really latency sensitive, you might probably have your own dedicated source that will be using IPC, inter-process communication for your market data source and your trading source.
That's good. Let me just jump on. We've still got a lot of open questions. So is Linux epoll or poll or select used in trading? If so, which one is better? And someone's already answered that. Andrew Nellis. Is there anything to say about that? I'm not sure I really understand the question.
Yeah, that's not an area that I'm hugely familiar with. I know that was abstracted in some of the libraries I've worked on, but it was not something that I'd worked directly on.
Okay.
I assume epoll is used, but it's only educated guess. When you build a server which should do an reactor, essentially, you use essentially epoll because this is available on Linux. It's faster than a select call. Okay.
Yusuf asks, what are you thinking about that Linux used to use to Rust language or on kernel?
Yeah, there's newly it's newly been, I think it's now in this, is it 6.1 kernel there's either some Rust or there is Rust is now capable of being built into the kernel.
Yeah, I think Linus has come out and stated that it's the intent that Rust is going into the Linux kernel now. So that was obviously pretty big news for Rust.
Yeah, I think it's appropriate though. I someone asked on LinkedIn, about the Rust versus C++. There, is Rust a possible replacement for C++? And I said, well, it's more a replacement for C. And I feel that that's right, because to take, Rust has a very long way to go to actually sort of function from the point of view of its functionality, have any dent in C++. Some of the things we've talked about today, just the sort of the libraries, all the, concepts, concepts are a big deal, and that's not something that's a part of Rust, and it would have to change to take on that type of functionality. But Rust is a replacement for C in, applications like, kernels or, virtual machines and so on. I can see that having a lot of legs.
Anchor asks, in your high frequency trading implementation, do you use a lot of standard library? What can't you use? And have you a lot of value-based programming?
Yeah, so where I've seen it, the standard library is used everywhere because you would be absolutely insane to try and write that using your own library. And I say that coming from video games, where when I was in video games 15 years ago, it was very common for companies to write their own version of the STL. I worked for a studio that was owned by IDOS at the time, and IDOS had their own STL, EA had their own STL. I think nowadays STL implementations are standardized and good enough that you're really going to struggle to beat their performance. That said, Facebook clearly think that they can do better because they've wrote their own vector, and I think if anyone who knows about Folly, the library, they've got a vector implementation that has a different growth scheme, which they say gives them performance advantages. So I think it very much depends on your use case. What I will say is in high frequency trading, if you're using the STL, you are going to be careful about allocations. You are probably going to be using allocators. You're going to be making sure that in the critical loop, you are not going off and spending a lot of time doing allocations and deleting data.
Okay.
I'm just scrolling back through our previous chats, guys, because I remember seeing some stuff about a Microsoft library recently produced, which, if I understood it properly, effectively is a replacement for virtual functions. So it's a means of dynamic.
Proxy.
What's it?
Yeah, proxy. It's being proposed.
Proxy.
Yeah, it's been proposed for inclusion into the standard. So we were looking at the paper at the BSI just a week ago.
I find that quite amazing and exciting. I guess when you think about it, it's not so strange. But it's another example of sort of innovation within C++ that can. It's not just saying, okay, we're not going to use a standard library. We're going to throw out, a big part of the established part of the language, and you can do that. Right?
Absolutely. I mean, just look at there was a really good CPPCon talk a few years ago about the Mars rover, and the guy from NASA who was talking on that was saying that they had 10 megabytes of memory, so they had to pretty much throw out everything, write everything themselves, and no allocations, very deeply embedded environment. And C++ they could do that. And off the back of that, there's some work going on in the standard at the moment to do around what's called the freestanding library.
Exactly,
which is,
good point.
Yeah, basically giving you a minimal subset of functionality for embedded environments, because that there are people out there developing C++ on embedded systems that have to be very careful about the kind of things that they do.
Yeah, it's a sort of phenomenal the pace of development and the sort of solution making that's going on. None of this work is done sort of because very little of it is done because someone's got for a lot of free time and wants to do something cool. They solve real world problems, and once solved, that real world problem is taken away, and it drives some part of some industry forward a big chunk, and it's a part of what's allowing technology to go on this amazing march that it is going on.
This is a good point when you give such a vision, because you learn a complex programming language in a complex domain, and you want to know that if you invest your time in the right direction. And therefore, it's good to know that you know what C++ will get in the future, which makes it even better. So I think this is extremely important. You have only one life.
Yeah. I think job seekers now, if you're sort of early in the your career, if I wouldn't worry too much because you're spoiled for choice. Pretty much you can choose quite almost at random. Well, what I would say, choose on the basis of your fascination. What fascinates you the most? Use that fascination to generate interest, and then pursue that. And don't give up. Go right down to the detail of knowledge, because if you build it up and you really deeply understand the area that you focus on, whether it's FPGAs or high frequency techniques or things like the CPU caches. This is a great area and a huge area to get into. Programming with knowledge of CPU cache, instruction cache, and so on. Then just as one example, deeply understand it, and then you can show that to your interviewers. They will be as impressed, as rightfully impressed. You choose your area that fascinates you and dig deep into that, and you will get somewhere with that, and it will be reasonably lucrative if that's your a big criteria.
Someone asked, how stressful is the development environment in high frequency trading and fintech?
That very much depends on the company you're working for. I'm not going to mention any names here, but I've certainly I've worked at companies where production systems would crash regularly. That was just part of the day-to-day course.
Yeah.
And in those cases, traders would be turning up at your desks, screaming, pulling their hair out, worried about losing millions of pounds or dollars. In that environment, you have to get things fixed very, very quickly. But it's very dependent on the company you're at and what their technology stack is like. Some companies have a very good stack, and lo and behold, they have far less problems. Other places are chaotic and they never have time for testing, and there's always too much work to do, and that feeds into the kind of pressure that you end up under as a developer, and that adversely affects the number of times that things go down in production.
I was working at an investment bank in Hong Kong, and it was really pretty high pressure. It was like they were market making options and so on and so on. And there's lots of there was technology was all right, but there was always some issues. Sometimes it was technology fault, sometimes not, and you would get. Pretty soon the traders know who the developers are. They don't want to talk to the manager; they want to talk to the developer, and they don't care. They don't even know who the manager is, and they know your phone number, and they're on the phone, and they're usually French, right? And it's sort of. Rishi, come up to the floor now. I'm bad with French accents. I live in France. I'm still bad with French accents. Up to the trading floor right now. And oh my God, up you're going. What's going on? Yeah, you're writing down, trying to give me a screenshot, send it to my email. Okay, and then you go on, you work on it, and maybe you get it fixed quick enough. Who knows? And there I was, and it was like, coming up to the end of the year, and I was hoping for, a lull in the end of year period, and guess what? Oh no, I see the number on my phone, pick up the phone, and it's Rishi, come up right now. Oh my God, what's going on? Oh no, it's like we're in the end of year change freeze as well. It means if I make a change, it's going to be going to have to be approved by basically God. This is going to be a nightmare. So I go up to the trading floor, go up to the guy's desk, and he turns around and goes, Rishi, you're here? Here, have one of these Christmas hampers. You get this huge, great Christmas hamper with all this expensive food, foie gras, and bottle of magnum of champagne in it, and so on and so on. So it's not always that bad.
I have to add, there's a reason why I'm an independent C++ trainer. There's a reason for that.
Yeah.
So sure. I know the companies you don't want to work for.
Right.
But by the way, this is not an issue. When you are good, you can easily leave and go to a better company.
That's the case, and that's a problem. It's a problem for the employers. It's a problem for the employers. It's definitely a you say, a seller's market these days, and I don't see that really changing that much. If you're on this call and you're numerate, you just get yourself on top of these areas. Put yourself your GitHub together, work hard, and you will. You get yourself a good career and a fascinating one, right?
With a lot of fun.
Yeah, really, yeah.
I think probably we should wrap it up soon.
Mm.
I mean, it has run over. I mean, last time we did go over for quite a while.
A bit too much. Yeah.
Don't mention it.
I think it's not friendly for the people in the Asia time zones. Actually,
Yeah.
next we will try and have a webinar in Asia time zone as well,
Mm.
some point soon. But for those people we didn't get around to answering questions, if you ask those questions on the Telegram, I'm sure we'll all chip in and kind of, I'm sure people would answer there, and both Anthony, Rainer, Richard, everyone should be able to answer there as well. So maybe I'll just, what do you think, guys? Shall we wrap it up here, or do you think there's anything else we should mention?
I think yeah, we can. I think it's a good time to wrap up. I don't think we'd ever get through questions really, because questions generate more questions.
Yeah.
But I've really enjoyed it, and I always find it sort of exciting to interact with the community like this, and get back to the Telegram.
Apart from Telegram, how should people keep in touch or find out about what you guys are doing?
I'm happy for people to to go to my LinkedIn. I think you shared that there, and that's one way.
Guess
the same holds for me. Of course, I'm quite visible, or pretty visible in the internet. Therefore, you can just write me an email, and if you want to know something special about C++, about classes, about Python, about mentoring, I am happy to answer it.
And Rainer also has a very great website, lots of resources.
Okay, I forgot it anyway.
Yeah,
I'm better in marketing.
All you have to do is search for some C++ area, and Rainer's modern C++ comes up in the first, second, or third. Typically, don't know how you do that, Rainer, but well done.
Yeah.
Yeah, and okay, great. Maybe we'll just stop it there. And just before you leave, there will be a poll, or sorry, a survey at the end of the webinar. So please do answer those questions. That'll be really helpful for us to produce more of this type of content and do more of these type of webinars. But I'm sure we'll all be back again, hopefully sometime soon. And we'll run to more of these questions.
Yeah, great. Thanks everyone for coming along.
Yeah, thanks everyone.
Okay,
Thanks.
bye.
Thanks.
Good to see everyone. All right, cheers.
Bye.
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 Bye.